Hello, welcome to limit laws. Okay, so we have different limit laws here. So I will let you know what are these limit laws. So as you can see, we have different kind of limit laws. Okay, for a while. Okay, so we have limit 1, limit of a constant, limit 2, limit of the identity function, limit 3, limit of a constant times a function, number 4, limit of a sum and difference, limit 5, limit of a product, limit 6, limit of a quotient, limit 7, limit of radical, and what else? Limit 8, which is limit of a power. Now, in limit laws, we will be applying these in a given limit function so that we would be able to know what if that limit exists or not. Okay, so now let's start with an example here. Okay, so as you can see, we have different limit laws, like what I've said. In limit of a constant, we have here if limit of c is equal to c, meaning to say your constant here, if you have a constant here, then the result is a constant. In identity function, if you have a variable here, what are you going to do is we will just substitute the value of our x, which is here a. So whatever your x here, you'll just have to substitute. For L3, limit of constant times a function wherein your constant, okay, for example, c times a function, then your constant will be separated to your f of x. Okay, so to apply the limit laws, and then sum of difference or difference rather, we just have to separate the f of x and then the g of x. So each terms will be added limit or the word limit as x approaches to a. Okay, and then for the limit of a product, the same with the sum and difference, we will just separate them. In separating, we will put limit as well in every terms. Okay. Now, limit of a quotient, we just have to, again, we will just be putting or writing limit in the numerator and denominator to apply this limit law. And then for L7, the radicals, wherein we will just put the limit inside of the radical sign, okay, inside, okay, the radical sign or in the radicand. So as you can see, the limit here will be added in the radicands. And the limit of a power, as you can see also, the limit of a function wherein n is your power here, the limit will be applied or be written inside the parentheses or in a group of a power. Okay, so lalagyan lang natin siya ng limit. Okay, now for example, we have here limit of 2x plus 5 as x approaches to 3. What are we going to do is to apply lang the limit laws that we have. Okay, so what will happen here is that the given is already what limit law is this? This is okay, sum and difference, because as you can see there is an addition here or an operation which is addition. So limit of and 2x as x approaches to 3 plus, like what I've said, you have to add all the terms by limit plus limit of 5 as x approaches to 3. Okay, so as you can see, we just applied here the limit laws. Okay, so let's have the next one. So the next step here, actually, we can still be applying the limit laws constant times a function, but either this way, we can proceed to the next step na lang. Okay, so we have here, apply the limit limit constant times a function, di ba, magiging 2 limit of x siya, okay? But we can actually, omit na lang this one and proceed since we already applied the limit laws here so that you would be able to, disregard it na lang. So let me erase this one. Sorry. Let me erase this one first. Okay. So apply the limit laws. Okay. So we have here 2. Okay. The color, let's have blue. 2 times, what is your x here? The approach is 3, right? So we will be substituting x by 3. So 2 times 3, okay, plus 5 by using the limit of a constant. So we have here 2 times limit of 3, 2 times 3 plus 5, that is equal to 6 plus 5, that is 11. So the value here is 11. Okay, that's how we apply limit laws. But it's up to you if you will apply the limit of the constant so that you would be able to determine if you really understood it or not. Okay, so that's it. Let's have another example for this. Okay, let me erase everything. Okay, so as you can see, we have here limit of 5 over x plus 3 as x approaches to 3. Now, what are we going to do is we will be applying the limit laws. So what limit law are we going to apply? Okay, as you can see, that is quotient, right? So there is a numerator and there is a denominator. So what are you going to do is to apply the limit of a quotient. For you not to be bothered or to have a long method, you can actually apply both. All the limit laws so that you would be able to proceed to the next na lang. So we have here limit of 5 as x approaches to 3, since that is the approach, over, okay, so it's kinda, ayan, over, okay, for a while, let me erase lang this one. It should be on the here so that it would be, in the middle. Okay, so we have here limit of, apply na lang natin lahat, limit of sum and difference, since the denominator had I plus in operate in I mean the operation is plus or addition. So limit of x as x approaches to 3 plus limit of 3 as x approaches to 3. Okay? So you can apply na lang everything so that it would be easier for you to have the process or solve the process. Okay? Now, the next step here is we will solve it now or evaluate. So apply the limit law. So this is limit of a constant. So that is 5 over, substitute the value of 3 into x. Okay? Substitute the x into 3, sorry, by using the identity function. So 3 plus, again, the limit of a constant. So we have 3. So we have 5 over 6. So this is now the answer. Okay? That's easy. Okay. Now let's have another example for you to understand as well. So we'll be having more example for this so that we would be able to know how to solve the limit laws. Okay, next example. So for a while. Okay. For the next example, we have here limit of 2x over x minus 4. So, kanina, we just use, again, parang, ano na natin, no? This is very easy. So, limit of 2x, okay, or diretso natin, ganito, 2. Pwede natin i-apply sa limit of a constant times a function as x approaches to 12. Miss, is it okay if ganito na lang, limit of 2x? Okay, I will still accept that one because anyway, you will be applying it here man all the way. So, okay lang. Okay, sige, let me erase this one first. Okay, so next is, what we're going to do is, for a while. Okay, So we have here two limit of x by using the constant times a function over, of course, the limit of x as x approaches to 12 minus limit of 4 as x approaches to 12. Okay, so apply the rules 2 times the loss, sorry, the loss. So we have the constant function, so multiply lang natin, value natin, i-substitute natin yung value ni x, that is 12. So 2 times 12 over 12 minus 4 by using the identity function and then the constant function. Okay, so the answer here is, that is 2 times 12, that is 24. All right, so 24, okay, over, we will be subtracting 12 by 4, 12 by 4, so that is 8. So we can still divide this one, or reduce this one to lowest term, so that is 3. So the answer here is 3. So this is the final answer. Okay? Okay. Next. For the next example, okay, there is none example here. So let's